Hi everyone! Welcome back to Coding Fab. In today's video, we're diving into Pandas, one of the most essential libraries in Python for data analysis and manipulation. Whether you're working with spreadsheets, large datasets, or just organizing information in code, Pandas gives you powerful tools to handle it all efficiently.
First, we'll introduce what Pandas is and why it's so useful.
Then we'll explore key components like series and data frames. Next, we'll walk through how to load, explore, clean, filter, analyze, and finally, export your data. All right, let's get started. 1. What is Pandas? Pandas is a Python library used for data analysis and manipulation. It makes working with tabular data, like spreadsheets or databases, easy and efficient. For example, in Python, it looks like this. Imagine you have an Excel spreadsheet with rows and columns. Pandas lets you handle that kind of data inside Python, such as summarizing and cleaning the data. It's a powerful library for working with structured data like tables, CSV files, or databases. Series and data frame. What is series? A series is like a single column of values. Think of it like a list, but with indexes. Okay, let's look at the example. First, import Pandas library and name it as PD for short. So whenever you write PD, it means you're using something from the Pandas toolbox. Here you're creating a series with 4 numbers, 10, 20, 30, 40. Pandas automatically gives each number an index, a label starting from 0. Then the outputs show the series of numbers with index. dtype in 64 inches just tells us that the values are integers 64-bit. Next, data frame. A data frame is like an Excel sheet. It's a table with rows and columns. Each column is actually a series, and the whole table is a data frame. Here, data is a dictionary. It's a way to store data in key-value pairs. Name is a column heading with 3 values. Age is another column heading with 3 matching values. Together, it looks like 2 columns with rows of data. PD data frame means take this dictionary and turn it into a table. DF stands for data frame, which is like an Excel sheet or a table in a database. Now DF holds this table, including index, name, and age data. Two, loading data. Let's say you have a CSV file full of information like a list of students. With Pandas, you can load that file into Python and start analyzing it like a pro. Let's have a look step by step. First of all, make sure Pandas is installed on your computer. In your terminal or command line, type this. That's like telling Python, I want to use the Pandas library. If you're using a web-based code editor like Jupyter, you should be fine. Pandas is ready to use. Now let's import Pandas. This gives you access to all the Pandas tools and functions. We use PD as a shortcut name. It's just a common convention. Next, load a CSV file. A CSV, short for comma-separated values, is like a basic spreadsheet where values are separated by commas. Let's say you have a file called data.csv. Run this with the read_CSV method. Now the content of the file is stored in a data frame called df. Once you load the data, check the first few rows to make sure it works. You can use the head method. This shows the first 5 rows of the table so you can quickly glance at the data. If you want to see the last 5 rows, you can use the tail method. In addition, if you want to load Excel or JSON files, Pandas can also handle other formats like this. Three, exploring data. 1. Basic structure and preview. These methods are your first tools to get a quick overview of your data set. First, head method shows you the first 5 rows of your data frame. It's used to take a quick look at the top of your data and check if it looks okay. If you want more than 5 rows, you can pass a number like this. Next, tail method shows the last 5 rows of the data set. It's used to make sure the end of your data is as expected or to look for patterns at the bottom. Next, shape method tells you the size of your dataset as a tuple. This example means 7 rows and 5 columns. It's used to know how much data you're working with. Next, columns method returns a list of column names. It's used to see what columns your dataset includes, especially helpful when you have lots of columns. Next, index method shows the row labels, which are called the index. It's used to understand how rows are labeled, useful when slicing rows or reindexing. Next, info method gives a summary of your whole dataset. Output includes column names, how many non-null or not missing values, data types such as text, numbers, and so on. Also, total number of rows, very helpful for spotting missing values or checking if your columns are typed correctly. Next, dtypes method shows the data type for each column like this. It's used to check if a column is treated as a number, text, object, date, and so on. This matters for analysis and calculations. 2. Data summary and statistics. These tools help you understand what's going on with your numbers and categories. Perfect for spotting trends, outliers, or errors early on. First, describe. This gives you a quick statistical summary of all numeric columns. You'll get count, how many values, mean, average, minimum, max, standard deviation, and quartiles. It's quite useful because quickly shows you what's normal or extreme in your data. If you want to see everything, not just numbers, this gives a summary for all columns, including text, like names or categories. So you'll see count, unique values, top means, most frequent value, and its frequency. Great for mixed data. Next, value counts. This shows how many times each value appears in a column. In this case, it's useful to understand distributions between past yes or no. Next, unique. It shows all the distinct values in a column, in this case female and male. Next, and unique. Gives you the number of unique values in a column. This is useful when you're checking how diverse the data is, like how many different categories or names. The rest are basic math methods. Mean gives the average of each numeric column. Median gives the middle value of numeric columns. This is useful when you want to avoid the effect of extreme values, like one super high or low score. St gives the standard deviation, which tells how spread out the values are. Big standard deviation means a big spread. Values vary a lot. Small means data is tightly grouped. Min and max give the minimum or maximum value in numeric columns. 3. Data inspection and quality checks. This part is like being a data detective. You're checking if your data has gaps, errors, or duplicates before doing any serious analysis. First is null. This method checks if there are any missing values, like empty cells, in your dataset. True means this cell is missing. False means this cell has data. It's kind of hard to read at first. That's why we usually combine it with sum. That's next. Is null and sum. This is the magic combo. It shows how many missing values are in each column. This tells you that no rows in the score column are missing a value. Super useful for cleaning your data later. Next, duplicated. This method checks if there are any duplicate rows. This returns a series of true or false. True means this row is a duplicate. False means unique row. Next, duplicated and sum. You can use this when you want to know how many duplicate rows are there. And you can remove duplicates to keep your data clean. 4. Filtering and sorting. This is the part where you start asking questions like, who scored more than 80? Can I just look at the name and score columns? What if I want the highest scores at the top? Okay, let's go step by step. First, df column. You can access a single column. This is like saying, hey, just show me this one column. You can use this to see the values, do math with them, and apply filters. You can also access multiple columns. This returns a smaller table with just the columns you want. Very useful when you're preparing a clean view of your data. Also remember that when you access multiple columns, you need double square brackets. Next, you can filter rows based on a condition. The inner part checks each row. The outer part keeps only rows where that condition is true. You can filter by anything: age, gender, pass, fail, and more. Next, sort values. This sorts your data by a column, ascending by default. This shows your data from lowest to highest score. If you want the top scores at the top, just set ascending false. Five, group and analyze. These methods let you group data, find patterns, and make comparisons like, what's the average score for each gender? How do different columns relate to each other? Can I see multiple stats at once? Okay, let's break it down step by step. First, group by. This groups your data based on values in a column. This doesn't show results immediately. It prepares your data to apply a function like mean, sum, and so on. This example groups all the rows by the past column, so it will create one group for yes, one group for no. You can then apply functions. Next, group by gender score and mean. It means get average score by gender. This is a full working example of grouping plus analyzing. This tells you the average score for females and males, great for comparing groups. Next, correlation. It finds relationships between numeric columns. This method gives you the correlation matrix, how strongly two columns are related. +1 means strong positive relationship. 0 means no relationship. -1 means a strong negative relationship. This is useful in data science to see which variables move together. Next, aggregate. It allows to perform multiple summary functions at once. Saves time by showing multiple stats together. Great for a quick summary. Four, cleaning data. We touched on this briefly in the previous section, but let's go into it in more detail in this section. 1. Checking for issues. Think of this step as the health check of your data. Before you clean it, you need to know what's wrong, like checking for missing values or duplicated rows. Let's go through it one by one. First is null. It checks if each cell in your data frame is empty, null, or nan. A true means the value is missing. In this case, no missing values. Next is null and sum. This counts how many missing values are in each column. Very useful for quickly spotting which columns have problems. Next, duplicated. It checks for duplicate rows, rows that are exactly the same as the previous one. A true means that this row is a duplicate. In this case, these are no duplicates. Next, duplicated and sum. It tells you how many duplicate rows there are. It says no duplicated rows. Two, handling missing data. Think of this as the part where you fill in the blanks or remove messy rows so your data behaves nicely when you analyze it. Missing data is very common in real-world datasets, so knowing how to handle it is super useful. Let's go through it one by one. First, drop NA. It removes any row that has even one missing value. For example, let's say you have student data with their age and scores. The number 5 and 6 students' age and score is missing. If you run drop NA, their rows get deleted. It's good when you don't want to deal with missing data. Also, you have enough data left after dropping. Next, drop NA with subset. This only removes rows where the specific column is missing. In this case, only the last student with missing data in the score was removed. So you're okay with missing data in other columns. It's good when you only care about missing values in important columns. Next, fill NA. It fills in missing values with 0 or anything else you choose. This keeps all rows and just replaces the blanks. This is good when 0 is a safe or default value. Also, you're not sure what the missing data should be, but you don't want blanks. Next, fill NA with the mean value. It fills missing values with the average of the column.
In this case, the average score is 72.5. All missing scores will be set to 72.5. This is good when you're working with numeric data. Also, you want to keep the data balanced instead of dropping rows. Next, interpolate. Fills missing values by guessing the next value using interpolation, like connecting the dots. Example, if the previous score is 70 and the next one is 90, it might fill the missing one as 80. It's good when you're working with time series or sequential data, and you want smooth logical values.
3. Fixing duplicates. This is the part where you clean up repeated rows that could mess up your analysis. Imagine you accidentally copied and pasted the same line in Excel. These tools help you find and fix that. First, drop duplicates. It removes any rows that are completely duplicated, meaning every value in that row is the same as another row above it. In this case, the second Alice row is removed. This is good when you want to keep only unique rows, and you accidentally have repeated entries. Next, drop duplicates with subset. This removes rows that have the same value in just the specified column, even if the rest of the row is different. In this case, it keeps the first Alice and removes the second based only on the name column. So this is good when you only care about uniqueness in one column, and you want to avoid double counting people or items. 4. Fixing text data. This part is all about cleaning messy text, which is super common in real-world data. People might type things in different cases, add extra spaces, or misspell things. These tools help you tidy it up. First, string lower. It converts all text to lowercase, like in this example. It's useful before filtering or grouping text data. Next, string strip. It removes extra spaces from the beginning and end of text like this. This is super useful when data comes from messy sources like manual input or web scraping. Next, replace. Replaces one specific value with another. This is great for fixing typos or abbreviations. Next, replace multiple values with one. Let's say you have a list that includes mixed M value in the gender column. This method can replace all those values with one value, so you can save time by replacing a list of incorrect values at once. 5. Fixing data types. In real-world data, columns don't always come in the format we need. Sometimes numbers are stored as text, or dates look like random strings. These methods help you convert columns into the correct data type so you can work with them properly. First, as type, it converts the column to integers or whole numbers like 10, 25, 100. Example, let's say you have a data set of students. Originally, the age data is stored as an object or string. By using asTypeInt method, it's converted to integers. You can use this when you want to do math or analysis, and your column is numbers but stored as text. Float and string are the same. So whether you're working with numbers, text as type, adjust the type to fit your purpose. Lastly, to date time. It converts a column to date time format so you can work with actual dates and times. Example, let's say you have a data set like this. Even though it looks like dates, these are just strings right now. Then use the method to convert to date time. Now Pandas recognize the column as real dates, not just text, so you unlock a lot of cool tricks like filtering by date ranges like this. 6. Renaming columns. When working with data, you often want to make column names cleaner, shorter, or more meaningful. Pandas makes this super easy. First, the rename method. It renames one or more specific columns by passing a dictionary. In this case, old name score is replaced with new name exam score. Of course, you can rename multiple columns at once, too. Also, don't forget, to make the change permanent, assign it back. Next, you can also replace all column names at once by setting a new list like this. You can use it when you want to rename all columns quickly. and you're okay with setting the order manually. Please make sure the number of new names matches the number of columns. Otherwise, it'll raise an error. 7. Dropping columns or rows. This is how you remove things you don't need in your dataset, like unnecessary columns or unwanted rows. It's like tidying up your spreadsheet before doing anything fancy. First, drop columns. It deletes a single column from the data frame. What is axis equal 1? Axis equal 1 means columns. Axis equals 0 means rows. In this case, the score column is deleted. Next, drop rows. This removes rows based on their index number or row labels. In this case, it removes the first 2 rows. It's useful when you spot incorrect or duplicate rows and you want to remove headers or test data. Next, drop multiple columns at once by listing them. This is cleaner and more readable than writing axis equal 1 when dropping multiple columns. 5. Selecting and filtering. We touched on this briefly in the previous section, but let's go into it in more detail in this section. 1. Selecting columns. This is how you choose specific columns from your dataset. First, this is the most basic way to pick one column from your data frame. It returns a series. It's a one-dimensional list of values. Next, select multiple columns. This is how you pick 2 or more columns using the double square brackets. Turns a data frame, not just a single column. The last one is for listing all column names. It shows you all the column headers in your data frame. This is used to check spelling or formatting, and it's useful when looping through column names or doing bulk renaming. 2. Selecting rows by index. When you want to zoom in on specific rows, you can use lock and iLock. These are powerful tools that let you grab rows based on their position or label, just like selecting specific lines from a notebook. First, lock. In this case, it returns the row where the index label is 0. You can use this when you want to access a row by its label, not just its position, and you've set a custom index like names or IDs. Next, iLock. In this case, it returns the first row of the data frame. Use this when you want to access a row by number, and the position of the row matters, like top-end results. So the difference between lock and iLock is lock uses label name. On the other hand, iLock uses row number. Next, iLock with a range of rows. This example means selects rows from position 1 up to 3, but not including 3. So it returns row 1 and 2. So you can use this when you want a range of rows. This is like slicing a list. Next, iLock with specific rows. This example means selects rows at index 0 and 2, returns the first and third row. So you can use this when you want to pick specific rows, and great for looking at certain examples or comparing rows. 3. Filtering rows by condition. Filtering means only show me the rows that meet a certain condition. It's like applying a filter to your spreadsheet so you only see what you care about. First, filtering with numerical values. Example. This returns only the rows where the student scored more than 80. You can use this when you want top performers and you're filtering numerical values. Next, filtering with categorical values. This example gives you only the students who passed. You can use this when you're filtering based on categorical values such as yes, no, male, female, and so on. Next is in. This example returns rows where gender is either male or female, can be expanded to more categories. You can use this when you're checking if a value is in a list, and great for filtering multiple conditions easily. Next, string contains. This example means if a student's name has the letter A in it, the row will be included. You can use this when you're filtering based on text content, and you want to do simple keyword searches. Next, between. This example only shows students whose scores are in that range. Next, not. The wave symbol means not. This example filters out rows where passed is no, so it only shows who did pass. So you can use this when you want to exclude specific values from your results. Four, combining multiple conditions. This is like saying, show me students who are over 20 and passed, or show me students who are either female or scored above 85. Let's break it down one by one. First, combining multiple conditions with and. This example says rows where age is over 20 and passed is yes. Age is over 20 inches is condition 1. Passed is yes is condition 2. That means both conditions must be true. So the results gives you the students older than 20 who passed. Make sure to use round brackets around each condition. Pandas needs those to know how to handle the logic. Next, combining multiple conditions with or. The example means rows where gender is female or score is above 85. So you'll get all rows where the student is female or again the score is more than 85. The last one filters out rows where a value is missing in a specific column. Is null finds missing values, then returns true for missing. The wave symbol means not, so it keeps only rows where score is not missing. This is useful for cleaning your data before analysis and avoiding errors caused by missing values. 4. Combining multiple conditions. These are extra powerful tools to filter, sort, and quickly grab the top or bottom values from your dataset. You'll use these a lot when doing reports, summaries, or dashboards. First, filters using SQL, like query syntax. This does the same thing as we learned in the previous page. It's shorter and easier to read, especially if you come from a SQL background. Next, sort values. In this case, it sorts rows by the score column in ascending order, lowest to highest. If you want to change the order, you can use ascending false. It sorts rows by score in descending order, highest to lowest. Great for finding top performers or best results. Next and largest. This example means gets the top 2 highest scores. Use this when you want to quickly get top n values. It's much faster than sorting plus slicing. On the other hand, n smallest returns the top n smallest values. Six, analyzing data. Analyzing data uses all the tools that we learned so far. Because analyzing data is for looking closely at your dataset to find patterns, insights, or answers to your questions. It's like being a detective. You ask questions and use the data to find the answers. Also, in other words, data analysis is the step where you turn raw data into meaningful information, helping you see the story the data is telling. Seven, exporting data. You can export your data to a variety of data types in the ways shown here. First, export to CSV. This is the most common format for saving and sharing data. It creates a simple text file with comma-separated values. It can be used when you save cleaned data for reports or sharing with others. Next, export to Excel. This is useful when you want to work with your data in Microsoft Excel or send it to someone who prefers spreadsheets. Next, export to JSON. This is used for web apps, APIs, or saving data in a structured text format. JSON is very popular in web development. Next, export to dictionary or list. Good for converting data into Python native structures to use in further code or logic. Next, other export formats. Includes options for saving data to a SQL database, copying to clipboard, or exporting as HTML, Markdown for websites or documentation. And that's it for today's lesson on this topic, Pandas in Python. We covered the core concepts from loading and exploring data to cleaning, filtering, analyzing, and exporting. Hopefully, you now have a clear understanding of how to work with data using Pandas and why it's such a powerful tool in your programming toolkit. Okay, thanks for watching today's lesson on Coding Fab. I hope you found these tips useful and feel more confident. Remember, practice makes perfect, so try using these tips in your project. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more fab coding lessons. Until next time, keep practicing and stay fab.